So we will continue for our discussion on coordinate systems. We were discussing few things and we'll continue that. So actually the transformation of axis we want to discuss now. As stated earlier, coordinate systems are essential for studying the equations of curve using the methods of analytic geometry. To use the method of coordinate geometry, the axes are placed at a convenient position with respect to the curve under consideration. If the curve, parabola, ellipse, hyperbola, etc. is not situated conveniently with respect to the axis, a coordinate system should be changed to place the curve at a convenient familiar location and orientation. The process of making this change is called transformation of coordinates. There are basically two types of transformations: shifting of origin, that is translation of axis, and rotation of axis. So basically there are two types of transformations. Shifting of origin. Origin, if you are shifting from one location to other location. Shifting of origin. There is translation of axis and rotation of axis. Rotation of axis. Shifting of origin and translation of origin. Rotation of axis means axis orientation is changed. Shifting of origin or translation of axis. The shifting or translation of an coordinate system is done without rotation, so that each axis remains parallel to its original position. Let point P has coordinate x, y in original coordinate system, that is in xy coordinate system. If the axes are translated, a distance h to the right and distance k upwards, the origin takes new position as h k. The coordinates hk are with respect or to original coordinate system. Let the new axis define the plane xy, capital X, y coordinate system. The coordinate of the point P are now x comma y, that is x minus h and y minus k. Why are we doing minus here? Because shifting is there. The original x minus h is there. It is shifted to right hand side, and y, whatever y we are having, minus k, because k is deducted from the y also. So capital X is equal to x minus h and capital Y is equal to y minus k, or small x is equal to capital X plus h. Okay, small x is equal to capital X plus h, and small y is equal to capital Y plus k. Coordinate 0, 0 of the old origin referred to the new axis as minus h. So the coordinate 0, 0 of the old origin referred to the new axis are minus h, minus k. If the equation of the curve with respect to the original coordinate system is f function of x comma y is equal to 0, then its equation with respect to new coordinate system will be f x plus h, okay, f x plus h comma y plus k is equal to 0. That is in equation, that is in equation. Replace x by x plus h and y by y plus k. Okay. Equation of the curve with respect to origin equation with respect to a new coordinate system will be f x plus h comma y plus k is equal to 0. That is an equation f x y is equal to 0. Replace x by x plus h. Small x plus h, because function is there. Coordinates 0, 0 of the old origin refer to the new axis. So minus h minus k reference is correct. A function also, in place of x we have x plus h, x plus h. Okay, and y plus k. So this is a y which is important for us. Okay, mark R here. So this is also important to understand. Let me just rotation of axis about origin. Another type of transformation of axis is rotation of axis. Consider pxy in original coordinates system, that is xy coordinate system. Let these axes be rotated by an angle theta in anti-clockwise direction about origin to the new form capital XY coordinate system. Let us find the coordinates of P with respect to a new coordinate system. In the figure, SR is equal to x perpendicular upon base as that is x tan theta, and OS is x sec theta. OS is x sec theta. Okay. OS is base upon hypotenuse, so base x upon so hypotenuse upon base. Okay, sec theta is the hypotenuse upon base. So x OS is equal to x secant theta. PS is equal to y minus x tan theta. PS is equal to y, small y I am saying here, y minus SR, that is x tan theta. SQ is equal to PS I have done. This angle is theta, so this angle will also be theta, and here this angle is also theta. Why we have this theta? The reason is okay. So in this case, what will happen? SR we have calculated. PS we have calculated. SQ we have calculated, that is capital X minus x tan theta, that is OS. In triangle PQS, have already with us PS we are having and SQ we are having. Okay. So SQ upon this we can do an X from here, capital X. From here we can calculate this, and cos theta is base capital X we have taken out from here, and capital Y 1 into small x is equal to X capital X. So capital X is equal to small x cos theta plus y sin theta. Capital Y is equal to minus x sin theta plus y cos theta, from 1 into x comma y x capital X cos theta minus y sin theta. Conversion of coordinates from one system to another system can be written as capital X cos theta sin theta. So okay, we'll have to see this. Small x is equal to x cos theta, and how it came. One into axis is interchanged. Similar study with axis is interchanged. Okay. Capital X, small x, capital Y we have got, but from 1 into how we have got small x is equal to x cos theta minus y sin theta. That is not very clear. The conversion of coordinate from one system to another, you can say capital X is equal to x cos theta plus y sin theta, and capital Y is equal to, so small x is equal to x cos theta minus y sin theta, and yeah, this part needs to be understood again. Okay, this one, not this one. So this part I'll just re-understand. Okay. So conversion of coordinate from one system to another system can be printed as follows. Small x is equal to capital X cos theta minus, and small y is equal to capital X sin theta and y cos theta. That's fine. Okay. So page number, we'll continue with this lecture. Right now I've not written anything because I'm following with this particular book. So we'll come back to this. So we have some slight confusion here, and that we have to clear. Rotation about origin we are calculating if the equation of the curve is vector, so rotation about that we are calculating. Okay, we'll come back to this in short time maybe. So we have to just work on this area. It's a very important